Okay, today we're gonna continue electricity. We're gonna draw some basic circuits to get the idea to apply the components we learned in the previous lessons to apply them in actual circuits. Okay, to start up, prepare a fresh paper. There's no need to draw a title block because it is written on the other side. And we're gonna divide the paper into four. We're gonna do one circuit in each space provided. Okay, so when we were doing the designs, the components, the items we mentioned in series and in parallel. So now I'm going to explain what actually they refer. Okay, basically here I have two circuits. Okay, the first one on the left is made from two bulbs, and here we have an ammeter. Okay, to give you an idea, here is written battery operated circuit in series. In series, it is very easy to understand. It is like a chain circuit. It means one is connected to the other. Okay, so the only problem with the series is that if one of the component it is damaged, let's say we have a light bulb here and it goes off, it's not working anymore, then this circuit it will be interrupted, and because of that even the other bulb it won't work. Okay, so if we connect all the components in series, they all will work until a failure will happen, because if something fails, then all the circuit will fail, and we have to check each and every component to replace. So it is not very easy to do, convenient. Okay, here we have a battery operated circuit. So to draw the circuit, just prepare a rectangle. For now, do it faint line, construction line. Then draw all the symbols. Start by the battery, draw the two bulbs, and here we have the ammeter. The ammeter, as we said, is connected in series. In series, it means it's part of the chain. You just place it in the circuit continuous. Okay? Basically, that is the first circuit. The second circuit is identical. It's battery operated as well. I'm referring to this. Okay? It's battery operated as well, but the bulbs are connected in a different way. They are like bridged, It's called in parallel. So the benefit of this arrangement is that if one of the bulbs is not working, it's faulty, the other one still works. Okay? That is the same situation we have in our homes, how all the lights are connected. They are connected in parallel, because if the kitchen bulb is not working anymore, all the others are still working. If I had to connect the light circuit of our home in series, I will have serious problems because if the kitchen light it goes off, all the house it will go off, and then I have to check each and every bulb to replace. So it's not very convenient. So the parallel is a better option for the light circuit. Both are connected in with a battery operated, so direct current. Okay, so take time to design these two circuits. All right, now we have to discuss another two circuits. I'm going to remain on the same idea. The only difference I'm going to change is the power supply. Instead of a battery, I'm going to do a high voltage supply. So here we have a main operating system like we have in our house, high voltage. If I connect these direct with the bulbs, probably they will not work, they will burst. So I need to do a transformer, a step down transformer. And this is the right method how to design, how to connect a transformer. First thing, when we did the description lesson, the transformer was drawn like this. Okay, here I'm gonna show you how it is connected on a circuit diagram. So basically, here we have the symbol for the electrical main supply. Okay, as we said, 240 volts, high voltage. Here we have the transformer. Okay, in this case, on the description lesson, I label them as circuit A and circuit B. I'm gonna place these so you can easily understand. So look, so circuit A, it is high voltage. Circuit B, it is low voltage to accommodate for the bulbs. Okay, so basically it is called a step down transformer. Okay, so basically that is the arrangement for the circuit. So whenever we have a high voltage instead of battery operated circuit, usually we need to do a transformer. In an exam situation, they will give you all the components and we need to arrangement together. So you're not gonna discuss or basically decide if you're gonna do a battery operated circuit or a high voltage circuit, but we'll get to that later on. For now, during these lessons on YouTube, I'm gonna show you the basics. Then hopefully when we meet again at school, this topic we're gonna get it more into detail, because this is not the right way to explain this topic. Okay, I will show you more exam questions, we discuss them, we reason things, and we design more circuits. But for now, I'm gonna show you these four circuits. Okay, so here we have the bulbs connected in parallel, and we have a transformer step down, and we have the main supply. The last circuit is basically the same. The only difference is that the bulbs are connected in series. So in real, that is not the right way, but it is also a circuit and it still works, to be fair. So that's why I'm giving you these arrangements. Alright, so in the last two diagrams we have high voltage, transformer step down. The first idea was two bulbs connected in parallel, and the other was two bulbs connected in series. For now, for this topic electricity, if you manage to understand at least the items listed in the first lessons, okay, you know the idea what each item is used for, and you understood these four diagrams, for now it is enough for electricity. Okay, so I'm gonna go through them again. Basically, the circuits we have in series and in parallel. It is very important to know the difference. In series, it is like a chain, one item just connected with the other. In parallel, we design them like they are in a ladder. Okay, in each ladder step, you put a component. If you understand this, you will do parallel very easily. Basically, for the because you may ask, so what is the difference? Is it where did use this or where did use the other one? If I had to connect the battery operated in series, the first example, top left, okay, um, the battery in real will last longer. In the second, in the parallel connection, the battery will last um, uh, will last less, because it's giving the same power to both the bulbs at the same time. Okay, but when we connect with the main supply, that is not gonna affect us a lot. So it's got the bronze, and it's got